I'm Rajesh Uppal, Director IDST. We bring sharp insights and foresight on defense, security, and emerging tech. Let's dive in.
Imagine a world where designing and building aircraft, spacecraft, and satellites isn't bogged down by endless delays and inflexible processes. Instead, innovation happens fast, collaboration flows across disciplines, and every setback becomes a learning opportunity. Welcome to the future of aerospace, where agile engineering is taking flight. For decades, aerospace development followed a rigid, step-by-step model called the waterfall methodology. Think of it as a relay race. Each team passes the baton after completing their part. First comes meticulous planning, followed by design, development, and finally testing. If a problem is found during testing, well, you go all the way back to the start. This makes projects slow, expensive, and vulnerable to disruptions, especially in today's fast-changing world. But the aerospace industry is facing intense pressure. Technological leaps like artificial intelligence, 3D printing, and sustainability mandates such as hydrogen propulsion or carbon-neutral materials. Plus, supply chain disruptions during the pandemic exposed the waterfall approach's critical flaws. A 2022 study by McKinsey showed that 70% of aerospace programs exceeded budgets, and nearly half missed deadlines under traditional methods. Enter Agile Engineering. Borrowed from the software world, Agile is all about iteration, rapid prototyping, and constant feedback. Imagine cross-disciplinary swarms of engineers, mechanical, electrical, and software working together in sync. No more silo teams handing off incomplete designs. Instead, small functional prototypes are built fast, tested, and improved repeatedly. How does this work with physical hardware? You can't just rewrite code overnight. But thanks to 3D printing, laser cutters, and digital fabrication tools, engineers now create real parts in days instead of months. These prototypes are tested, feedback is gathered, and improvements are made all in real time. Think of it like sculpting a model airplane, refining it with every try, rather than waiting for a massive final version. One powerful example is the Boeing T-7A Red Hawk jet, developed in just 36 months, compared to the usual 5 to 8 years. How? Digital twins virtually replicate aircraft to simulate over 100,000 real-world scenarios to predict how planes will perform, dramatically reducing the need for expensive physical testing. Similarly, Rolls-Royce's UltraFan engine employs AI-driven simulations to model performance under countless conditions, helping engineers spot and fix problems before building anything in the real world. Planet Labs, pioneers in small satellites, don't wait for perfect designs. Instead, they launch inexpensive Dove nanosatellites in batches. Even if some fail, the system keeps working, while customer feedback guides improvements. It's like learning to build better drones by launching early, adjusting after each flight. Late Decor, a French aerospace company, reduced aircraft door development time from 4 years to just 18 months by empowering engineers to make decisions on the fly, eliminating bottlenecks and unnecessary management layers. Additive manufacturing, better known as 3D printing, has transformed production. GE Aviation redesigned the LEAP fuel nozzle, cutting it from 20 parts into a single printed piece. This simplification makes the nozzle lighter, cheaper, and faster to produce, much like turning a complicated Lego set into a single block. SpaceX, famous for its rapid innovation, repeatedly tested Starship prototypes explosively and iterated fast, achieving orbital flight in just 4 years, a timeline previously thought impossible in aerospace. Supply chains are smarter too. Lockheed Martin now shares real-time production data with over 1,500 suppliers via cloud platforms, preventing part shortages and delays by instantly flagging supply issues before they disrupt production. Joby Aviation adapted automotive robots to rapidly assemble electric vertical takeoff and landing aircraft, cutting development time and cost by leveraging tools already perfected in car manufacturing. Of course, aerospace must meet strict regulations. Continuous documentation methods and modular certifications allow new designs to get certified piece by piece instead of waiting until the whole system is finished. Hybrid models now blend Agile's flexibility with the traditional waterfall structure. The Next Gen Air Dominance Initiative, for example, uses Agile for developing key subsystems while managing the full platform integration systematically. This means rapid innovation doesn't come at the cost of safety or reliability. What's next? AI-powered design tools will soon automate optimization, helping engineers instantly balance weight, cost, and strength. Imagine software that suggests the lightest material or safest design in real time, cutting guesswork entirely. Let's not forget the cultural revolution. Boeing's digital hangar trains engineers in AI and DevOps practices, preparing them to thrive in an agile world. Here's the bottom line. Aerospace companies that don't adopt Agile risk being left behind. Those who do enjoy faster time to market, lower costs, higher adaptability, and smarter designs. The race for the sky has changed. It's no longer about rigid blueprints. It's about agility, iteration, and continuous innovation. Thanks for watching. Subscribe, follow, or visit idsth.com for more cutting-edge defense and tech insights. See you in the next one.